So when an algorithm said to be an efficient algorithm, an algorithm is said to be an efficient algorithm when it takes a less running time and no it uses less space of the computer. See, when running time is less, I mean smaller, means that you are utilizing the smaller amount of CPU's time. So you are not letting CPU be busy by executing only your program. Okay. So you are utilizing only very less amount of CPU's time, means the performance of the CPU will be increased, right? So an algorithm which takes less amount of time, less amount of execution time or running time is called an efficient algorithm. Similarly, an algorithm which uses very less space or exactly a sufficient amount of space, okay, is called an efficient algorithm. So utilizing less space is one parameter, and utilizing less amount of CPU's time is another parameter to decide whether the algorithm is efficient or not. Now, let us see how to measure the running time of an algorithm. Okay, so running time of an algorithm can be measured like this. See, there are two different approaches. One is experimental study. By experimental study means practically we will implement the program, and after implementing the program, we will run the program with giving different inputs. Okay, so for different test cases, we will give different input instances, changing the size of the inputs, changing the various properties of the inputs. We will give various inputs, and we will see how much time is being taken by CPU to complete the execution of that algorithm. Okay, and all this. So this is actually possible only if you implement the program for the algorithm. Okay, and even to note down the running time, note down the running time, you don't need to look into the computer constantly. Okay, there are predefined methods which will give us the running time of the program. Okay, we will use those functions. We will call those functions in our program so that we can get it. But this experimental study is having limitations. What are the limitations? See, we are calculating the running time of an algorithm only to take a decision whether to opt that algorithm for the given problem statement or not. Because for the implementation, there would be a different implementation cost. Okay, so we have to decide whether to go ahead with this algorithm or not first. To take that decision, we are calculating the running time. But by experimental study means we are developing a program and checking it practically on the computer. So it is not at all a good practice for deciding an algorithm to a particular problem statement. Okay. So what is another method? The other method is, see, uh, we will calculate the running time without implementing the program. Okay, simply by traversing into the algorithm, by looking into the statements written in the algorithm, we can calculate the running time with simple mathematics. Okay, so by that we will decide whether to choose that algorithm for as a better solution for the given problem or not. Okay, right. Now we will see furtherly how to calculate running time without writing program. I mean before writing program itself. Okay, see, for your understanding, I took a program, but this is actually a program. Instead of this, we have to take an algorithm here. Okay, because program and algorithm looks the same, and here we are only doing theoretical calculation only. So we are not running it on a computer. That is why I took program for your better understanding. But here, instead of this program, we will apply this process on an algorithm. Okay, now assume this, we have a function called sum. Okay, and in this sum function is actually to calculate sum of cubes of n numbers. Okay, Now these are the steps. There are 4 steps to realize this, excluding declaration part, because the declaration count for no time, okay, in the execution. That is why we have omitted this. Now what is the first instruction? See, assume unit time. I am taking some unit time, that may be microseconds, seconds, minutes, whatever it may be. So I'm just mentioning it as unit time. So every sequential statement will take 1 unit time for the execution. So here sum is equal to 0 is a sequential statement, so it will take 1 unit of time. And here if you observe this 4th line, return sum will take 1 unit of time. Now come to the loop. Okay, this loop will be executed n number of times. By this logic you can understand that this loop will be executed n number of times. Okay, fine. In this, the second line, let us take the second line, okay, consists of 3 statements. One is initialization. Initialization will be executed only once, so 1 unit of time will be taken by initialization, and I less than or equals to n. This condition will be executed n times for trueness and 1 time for falseness. So totally n plus 1 times will be executed. Okay, so it will take n plus 1 unit times, and this I plus plus will be executed n times. Okay, and previously the first line takes 1 unit of time. Okay, and last line will take 1 unit of time. I am adding these two also here. Right, now let us get into the loop. Here the third line, sum is equals to sum plus I into I into I. Here it is having 3 primitive operations. One is I into I, next one is the result into I, and the third one is sum plus the result. Okay, so these 3 primitive operations will be executed. So it takes 3 units of time. It takes 3 units of time. And this operation, I mean these 3 operations will be executed repeatedly n number of times, because this kept in loop. So 3 into n units of time will be taken for execution of sum is equal to sum plus I into I into I. Okay, so what is the total time taken by this algorithm? 1 plus 1, 2, 3, 4, and 5n. 5n plus 4. So here you can observe this. The total cost is 5n plus 4 units. Okay, so this 5n plus 4 units is the time taken for execution of this particular algorithm. In this, we can ignore the constants 5 and 4. So the time complexity can be represented as big O of n. The time complexity can be represented as big O of n. So this is how we will calculate the running time of any algorithm. Okay. In order to do this, in order to calculate the running time of any program, okay, we have to remember few rules. I am mentioning few of the rules which will help us to calculate this running time more easily. Okay, so here see this. This example 1 consists of a loop. Okay, this loop will repeat execution of block of statements n number of times. Okay, let us assume that here you will be having some constant number of sequential statements. Okay, as we know, each sequential statement takes 1 unit of time. I am assuming there are 5 statements, so 5 units of time is taken for execution of this block, for block. Okay, and these 5 units will 5 statements will be repeatedly executed n number of times. So the total time taken for execution of this loop is 5n. And when in order to define the time complexity, we ignore the constants. So time complexity is n. So whenever you have a loop which will be repeated n number of times, then you can directly consider the time complexity as n. Example 2, see here I am having two loops. Okay, so nested loop, it is a nested loop. So outer loop, inner loop will be repeated n number of times and outer loop will be repeated n number of times. So time complexity for this is n, I mean inner loop is n, and this will be repeated n number of times. So total time complexity will be n into n, that is n square. So whenever you are having a nested loop with equal number of iterations, then the time complexity can be n square. Similarly, we will be having another example here. If you observe this, see here you are having a loop but with incrementation by 2. Incrementation is multiplied by 2. I is equals to I into 2. Okay. So here the incrementation is not by 1 or 2. Okay. It is incremented by multiplication. Okay. So the time complexity will be log n in these cases. Similarly, let me take another example where you will be having a nested loop. Okay, outer loop will be repeated n number of times, and inner loop is again log n number of times with log n complexity, time complexity. Okay, then this is log n time complexity, inner loop is log n time complexity, and outer loop will be repeated with n time complexity. So total is n into log n. So time complexity can be n log n in these type of cases. Okay. Similarly, we will take some other example here. If you see this, okay, here the incrementation is exponential. Okay, in powers. Okay, if you have a loop where incrementation is exponential, then the time complexity can be log n. Okay. Similarly, we will take an example 6 here. Last example I am taking here. You are having two loops, independent loops. Okay. And the first loop time complexity is m because it is being repeated m number of times. And the second loop time complexity is n. Then the time complexity can be written as m plus n. Okay. Right. So this is how we usually simplify the calculation of the time complexity. Okay. So this is the class for, topic for today. If you have any queries, please mark suggestions in the comment section. Uh, Thanks for watching.